We'll see about plotting and color even more in the next slide. So, why do we emphasize more on the plotting part? Is that uh, the analysis part is as important as the plotting part. Plotting will give you the better visualization of data, which will make you understand the data even more. So, when you know the plotting or the graphics or visualization part is almost as equivalent to the analysis part uh, ca- when you are when you want the product to be insightful. So now the default color schemes for most plots in R are like horrendous. Like the default schemes that R programming initially provided was not so good. So uh, uh, so I don't have a good taste, but like even I know that. So recently there have been developments to improve the handling and specification of colors in plots, graphs, etc. These are developed by numerous programmers who are supporting to the R programming community. So there are functions in R and in external packages that are very handy. We'll see about that in this session. So colors 1, 2, and 3. What do they indicate? Colors 1 is blank black, so plain white, and color 2 is red, and color 3 is green. So using the parameter call equal to 1, call indicates color. So you can generate data with random colors. So default uh, image plots in R. So when you take a graph, so when you take a XY axis and you want to create a heat map, so where exactly the densest point is plotted can be analyzed using a heat map. So basically, when you see this image, you'll get that most of the data is concentrated around this region, and this region being the lightest. This region is also the lighter regions, and this region is also lighter, but the denser regions you can see around. So this is a heat map and this is a topography map. So it will clearly like give you the contours of the data available, so in which will able to differentiate the other set of data from the remaining. So moving on, how to use the color utilities. Now, as I told you earlier, there is a package called GR devices, and this package will be used for the color utilities. So they have basically two functions. One is called the color ramp, and the other thing is called a color ramp palette. So these functions take palettes of colors and they help to interpolate between the colors. So the function colors is list the name of colors you can use in any plotting function. So you can test it whenever when you download this GR devices package. Right now I don't have this package, so I'll explain you in basics of whatever I created, whatever the slides I created. So the color ramp palette. What is that color ramp palette? It takes a palette of colors and it returns a function which takes value between 0 and 1. So it indicates the extremes of the color function. For example, if you take select the color as gray, between 0 to 1, the 0 will be the lightest and 1 will be the darkest. So it will indicate the extremes of the color palette for a particular function. Now, what is color ramp palette? So uh, it takes a palette of colors and it returns a function that takes integer arguments. So the basic difference is the integer arguments, and it returns a vector of colors interpolating the palette. So what happened in the earlier graph was this was heat dot colors. This comes from the color ramp palette. So it takes the input and it returns integers for each of the integer vectors which interpolates the palette. And this heat dot colors heat map or topographical map was created using the color ramp palette. So as you know, every color is constituted by red, blue, and green. It was mentioned as RGB. So now when you see a palette of 0, as you can see, uh, the red is marked as 255, and green is 0, blue is 0. So when you are seeing pal of 0, when you see pal of 1, you'll get 0 0 255, which means blue is 255 and green is 0 and red is 0. So pal of 0.5, when you want to divide, so it is actually indicating the extremes of the color ramp. So yeah, when you mix colors red and blue into the color ramp, so the extreme is 0 to 1. When it is 0, it will be extremely red, and when it is 1, it will be blue. And when it is in the midpoint palette of 0.5, it will give you red is 127.5 and blue is also 127.5, equally divided colors at the midpoint exactly. So as I told you earlier, 0 to 1 describes the extremes of the colors. So you can use the same function. You can create a sequence of 0 comma 1, length 10. So it ranges from 255 to 0 and 0 to 255, and always green will remain 0 because the function was created only for red and blue.